Good day to our lecturer, Dr. Nohaliza Binti Abu Bakar, and our fellow friends. Today, we are going to present about our PBL group project. We are Group 7 and our member consists of uh, Yong Chong Horng, SITI NURSHAHRINA Binti SHAMSUL, AUNI UZMA Binti AMIR, and me, which is Taming Singh. Now, let's get it started.
What is PBL? Project-based learning is a teaching method in which students gain knowledge and skills by working for an extended period to investigate and respond to a complex question, problems, or challenge. In this semester, we are instructed to make a PBL with our group members related to the topic of exponential growth and decay and Newton's law of cooling. Our objective during this project is to develop a deeper understanding of the topic we learn and also to improve communication skills while the project is in progress, and also, last but not least, to improve problem solving skill. Exponential growth and decay apply to physical quantities in which change in value or form in a rapid manner. The change can be measured using the concept of exponential growth and exponential decay, and the new obtained quantity can be obtained from the existing quantity. The formula of exponential growth and decay are fx is equal to a in bracket 1 plus r times t, and fx is equal to a in bracket 1 minus r times t. Exponential growth find application in studying bacterial growth, population increase, and money growth scheme. Exponential decay refer to a rapid decrease in the quantity over a period. The exponential decay can be used to find food decay, half-life, and also radioactive decay. Newton's law of cooling explains the rate at which an object changes its temperature when it is exposed to radiation. This change is almost proportional to the difference between the object's temperature and its surroundings temperature, given that this difference is quite small. The formula of this law can be used to calculate how quickly a substance at a particular temperature would cool in a particular environment. It also allows us to determine how the rate of cooling of an object depends not only on the temperature difference between the substance and the surrounding, but also on the constants of the substance. Newton's law of cooling formula is expressed by temperature of any time is equal to temperature of surrounding plus the difference between temperature of initial object and temperature of surrounding times e power of negative kt.
For problem statement, there will be two problems that need to be solved. First, question 7a, it's about exponential growth and decay, and question 5b, it's about Newton's law in temperature. For question 7, it's talk about in a particular culture, the rate of increase of bacteria is proportional to the number of bacteria present at time hours after the experiment. Given that the number of bacteria at the beginning is 10 power of 6 and after 1 hour it become 10 power of 9. So we need to find the number of bacteria after 5 hours, and the time is taken for the number of bacteria to be 3 times the original. In question 5, the problem state that on an evening at 6:15 p.m., VJ put a cup of hot caramel macchiato with an initial temperature of 100 degrees on a coffee table in his room with an internal temperature of 23 Celsius. Given that the temperature of the drink is 40 Celsius, after 10 minutes it is left, what will the temperature of the caramel macchiato be after half an hour? At what time will the temperature of that drink reach 30 Celsius?
Alright, so I'm going to talk about the Phyla table, part 7a. So the problem format is given like this. In a particular culture, the rate of increase of bacteria is proportional to the number of bacteria P present at time t hours after the experiment. Given that the number of bacteria at the beginning is 10 power of 6 and after 1 hour is 10 power of 9. Find A. The number of bacteria after 5 hours, and B. The time taken for the number of bacteria to be 3 times the original. So the facts given from this question is this. In the fact given is in a particular culture there is a number of bacteria. And the second fact is the rate of increase of bacteria is proportional to the number of bacteria P at times T hours after experiment. The third fact is the number of bacteria at the beginning is 10 power of 6. And the fourth fact is after 1 hour, the number of bacteria is increased to 10 power of 9. So the idea why the bacteria might increase is someone might have added additional bacteria in the culture, or the bacteria are reproducing in the culture, and perhaps the air might have some bacteria which landed in the culture. And fourth is the bacteria can clone themselves repeatedly, which increase their numbers. Then we are going to touch the learning issue. So the question we are going to discover here is, what is the formula of the number of bacteria P present at time T hours after the experiment? And the second question is, what are the unknown variables involved in this formula? The third question is, how to calculate the number of bacteria after 5 hours? And the fourth question is, how to calculate the time taken for the number of bacteria to be 3 times the original? Now we know all our questions and facts. We need resource to solve this question. The resource given is internet, Mac textbook, Mac guides, bacteria samples, library books, and tutoring. So, in this question of part B, which is question 5B, we got this problem. On an evening at 6:15 p.m., Vijay put a cup of hot caramel macchiato with an initial temperature of 100 Celsius on a coffee table in his room with an initial temperature of 33 Celsius. Given that the temperature of the drink is 40 Celsius after 10 minutes is left, what will the temperature of caramel macchiato be after half an hour? At what time will the temperature of the drink reach 30 Celsius? Well, so we from this problem format, we get the fact. At 6:15 p.m., Vijay put a cup of hot caramel macchiato on a coffee table in his room. The cup of so the second fact is the cup of hot caramel macchiato has an initial temperature of 100 Celsius. And the third fact is the room have an internal temperature of 33 Celsius. And the fourth fact is the drink is 40 Celsius 10 minutes after it is left. So now we got all the facts. We are going to think about ideas to as why to this happen. The first idea is the drink is cooled down by convection. The second idea is the drink loses heat energy to its much colder surrounding, which makes it colder. And the third is someone might have added ice into the drink. And the fourth, the heat is evaporated after the drink is left there for a long time. So now we got all. We need to learn the question needed to solve this question. The learning issues we got is number one. Is Newton's law of cooling needed to calculate the temperature of caramel macchiato after half an hour? The second question is how to calculate the temperature of the caramel macchiato after half an hour. The third question is how to calculate the time the drink's temperature reaches 30 Celsius. Now we got all the learning issue. We need the resource to solve this question. We need the internet, math textbook, science textbook, math guides, science guides, library books, tutoring, and talks in order to solve this question. And now my part is complete. Thank you.
So now I'll be presenting the solution part. We will discuss the first problem, which is the population. For A, we need to find the number of bacteria after 5 hours. We're using the formula initial number of bacteria times e to the power of RT is equal to the final number of bacteria. n naught times e to the power of rt is equal to the final n. So 10 to the power of 6 times e to the power of r times 1 is equal to 10 to the power of 9. E to the power of r is equal to 1000. Then we add ln to both of the sides. So r is equal to ln 1000 over ln e. Therefore, the rate r is equal to 6.91. Then we sub back r to the formula again. 10 to the power of 6 times e to the power of 6.91 times 5 is equal to the final n. Therefore, the number of bacteria will be 1.01 times 10 to the power of 21 after 5 hours. For the second question, we use back the formula again. 10 to the power of 6 times e to the power of 6.91 times t, the time, is equal to 10 to the power of 6 times 3. E to the power of 6.91 times t is equal to 3. Then same, we add the ln to both of the sides. 6.91t times ln e is equal to ln 3. 6.91t is equal to ln 3 over ln e. Therefore, we can get that the time taken for the number of bacteria to be 3 times the original will be 0.16 hours. For the second question, which is the Newton's law, we get that initial temperature of the drink is equal to 100 degrees Celsius. The internal temperature is 23 degrees Celsius, and the temperature will be 40 degrees Celsius after 10 minutes. So the question is, what's the temperature after half an hour, and how long will it take to reach the temperature of 30 degrees Celsius? The rate of change of temperature is directly proportional to temperature minus 23. So the rate of change of temperature is equal to K times T minus 23. dt over T minus 23 is equal to K dt. Then we integrate both sides. Integrate dt over T minus 23 is equal to integrate K in respect to time. Then ln T minus 23 is equal to KT plus ln C. Ln T minus 23 over C is equal to KT. T minus 23 is equal to CE to the power of KT. Then 100 minus 23 is equal to CE to the power of 0. Then we can get that C is equal to 77. Then we subtract C to the equation. 40 minus 23 is equal to 77 e to the power of 10k. So e power of 10k is equal to 17 over 77. Then t minus 23 is equal to 77 e to the power of 30k. We separate the 30k. T minus 23 is equal to 77 times e to the power of 10k times the power of 3. Then t minus 23 is equal to 77 times 17 over 77 to the power of 3. Therefore, the temperature of the caramel macchiato is 23.83 degrees Celsius after half an hour. For B, we need to find the times for the drink to reach the temperature of 30 degrees Celsius. So e to the power of 10k is equal to 10 to the power of 7. We add ln to the both sides. Therefore, 10k is equal to ln 10 to the power of 7 divided by ln e. Therefore, k is equal to negative 0.15. We subtract k to the equation. 30 minus 23 is equal to 77 times e to the power of kt. 0.09 is equal to e to the power of negative 0.15t. Then we can get that times is equal to 16 minutes. Therefore, it will take 16 minutes for the drink to reach the temperature of 30 degrees Celsius. So that's all for me. Thank you.
Based on the project that we have done, we finally get to acknowledge the topic that we study, which are population and Newton's law. In other words, we could solve any problems related to this topic. Other than that, due to a good cooperation from the members, we get to increase our interpersonal skills during this project was handled and able to be completed successfully. From what we could learn from the activity, we can relate the topic with real-life situations since many real-world processes are modeled using exponential growth and decay. When not constrained by environmental factors such as available space and nutrition, increasing microbes population, and indeed any growing population of any species can be described as exponential growth function. This can be proven in the problem-solving question in question 7 that we have done. It relates population of bacteria with exponential growth and decay. Last but not least, in the topic of Newton's first law of cooling, we could agree that the rate of heat loss of a body is directly proportional to the difference in temperature between the body and its surrounding. It can be used to predict how long it will take for a hot object to cool down at a constant temperature. It also helps to indicate the death time given by the probable body temperature at the death time and the current body temperature. This can be seen in our problem-solving question in question 5 that we solved that relates to real-time situation.